Just downloaded it from the file server, copy it to a thumb drive, and you're good to go.
This tells us two things right off the bat. Number one, that can't be SSL traffic, because if it was, we wouldn't be able to read that. Number two, there's a good chance that they actually are stealing something. Or maybe they're just copying a file to a friend.
Just downloaded it from the file server, copy it to a thumb drive, and you're good to go.
And I don't know if I would two things right off the bat. Number one, that can't be SSL traffic, because if it was, we would be able to read that. For number two, there's a good chance IP address they actually are out to stealing something. The 64.12 subnet, or maybe they're just copying. We see that that is also associated.
Downloaded it from the file server, copy it to a thumb drive, and you're good to go.
So we've confirmed there's right off the bat. Number one, that can't be SSL traffic, because if it was, we would be able to read that. For number two, AOL there's a good chance IP address that they are transferring a file. AOL 64.12 subnet, or maybe they're just copying. We see that that is also associated.
Downloaded it from the file server, copy it to a thumb drive, and you're good to go.
And if it's sending a right off the bat, number one, that can't be SSL traffic, because if it was, we would be able to read that. For number two, AOL there's a good chance IP address that they are transferring a file. AOL 64.12 subnet, or maybe they're just copying. We see that that is also associated.
Downloaded it from the file server, copy it to a thumb drive, and you're good to go.
So and if it's sending right off the bat, number one, that can't be SSL traffic, because if it was, we would be able to read that. For number two, AOL there's a good chance IP address that they are transferring a file. AOL 64.12 subnet, or maybe they're just copying.
Downloaded it from the file server, copy it to a thumb drive, and you're good to go.
So chances that they are, in fact, sending some files, but also confirms that this is AOL Instant Messenger, because only AOL Instant Messenger uses OFT2 protocol. So now we can look at this SSL traffic and determine that it's actually AOL Instant Messenger. So if you can right click the packet, select decode as, fortunately it's right there, AIM. Apply, and OK. And it's now converted all the SSL traffic into another filter for AOL Instant Messenger. And it starts giving us some additional data now that we have that decoded as AIM. It's actually showing who it's going to over here. There's a user that they are communicating to. So now that we've established that they are using AIM, which is Instant Messenger, there are ways to find out exactly what they're saying. And our goal here is to determine what happened on this network. So if we right click and follow TCP stream, this gives us a whole bunch of handy information, including some plain text, what they said. So here's the first message, here's the secret recipe, just download it from the file server, copy it and good to go, and we have a file name, recipe.docx. And down further, the other person responds saying thanks, and that they can't wait to sell it on eBay. And then they respond that they're apparently going to see them in Hawaii, apparently already planning to spend the funds there. So this is a pretty handy way to find out. Follow TCP stream is one of the best things in Wireshark, and if stuff is in plain text and not encrypted, then it's very easy to see what the communications are. But I want to go back to that OFT2 packet, because if there's a file being transferred, that is where it's going to be transferred, because that's a file transfer protocol. So if we follow this TCP stream, it's got doesn't look like much when you first look at it, but this is the one where the actual file is being sent. And yeah, you know, this is a pretty good amount of evidence right now that they're doing something they're not supposed to, especially with this file name. But, you know, who knows, maybe they're just giving them their grandmother's meatloaf recipe. So we want to prove that they're actually stealing, exfiltrating a file that belongs to the company. So when you have, in the follow TCP stream window, we can select only part of the conversation, and since the file is being sent from Ant's computer, we're going to just select her part of the message. And then you want to keep it in raw format, because in a minute we're going to edit it with a hex editor. call it recipe transfer or something like that. So we're going to open the, let me change the view on this. And this is a hexadecimal representation of the binary of the entire TCP flow that we just captured. So obviously this is going to include some headers and other transfer information that we don't want. So since we're looking for a docx file, which is considered a zip file to most systems, we're going to look for the magic number for zip files, because most files have a specific header to indicate what type of file they are. In this case, it is 504B or PK in ASCII. So that's the indication of where the file is actually starting and during the transfer. So we want to get rid of, if I can get this to cooperate, all of the stuff precluding that, because it's not part of the file. The way this particular protocol works, there's really nothing after the file in the sending process, so this is the entire file contents. So we can call this recipe.docx. At this point we should be able to open it, and there it is. Anarchy RS is recipe for disaster. Quick footnote is, generally in like an actual forensics investigation, we would not just open the file. You would make a copy of it and only work with the copy to ensure that the original is not tampered with in any way, so that way you can prove that they did in fact take the original file. And then from our command line, we would probably do a checksum of the file as well, so that, and you store that somewhere secure, so that way you can produce the original file later and give them the hash and say this is in fact the same untampered file that we discovered during the network transfer. So that's the scenario number one. We've proved that Anne did send messages to a rogue source, including transferring a stolen file, which is pretty cool. And got another scenario we can go through. This one goes that this takes place after Anne is busted for stealing the recipe file. She gets out on bail and then disappears. The police contact you as the forensic investigator and say, hey, we have a warrant and we've been capturing some network traffic from her for a little bit after her arrest. We think that she may have given some information to someone she knows on where she might have gone when she fled. Could you help us find it out? So we've got a new thing to work with, and they provided with us the MAC address that Anne's computer has, which is 002170-4D4FAE. So we're going to search for that so we can figure out which IP address we're working with.
And it needs that equals.
Oh, that's right. I'll try this one more time, but I remember off the top of my head what the address is, so if it doesn't work, we'll just skip ahead. Oh, it's 4F, that's why. There it is. So on her home network, she's got 192.168.1.159. So now that we have this, we can search through all of her traffic to determine, what she might be up to. So we scroll down a little bit. Once again, she's connecting to AOL, and we see some SMTP traffic, and we can confirm that because over here in the details information, it's got a name of a .mx.aol.com server, which is a email server. So another cool tool, though a lot of the ones in Wireshark are really handy. Another cool tool you can use to search for stuff through PCAPs is ngrep. And the -I option is to let it know that it's a PCAP file that we're going through. And then you just search for whatever indicator you're looking for. In this case, we're going to search for a name because that usually shows up in emails. Wrong folder. So we got a couple emails that popped up. She's sending from her laptop. It's got her name right here. This one, the subject is lunch next week. And message down here, sorry I can't do lunch next week after all, I'm heading out of town. So there's first evidence that she's planning to skip bail. And then the next email is going to a Mr. Secret X at AOL, obviously a law-abiding citizen. And says, hi sweetheart, bring your fake passport and a bathing suit, address equals attached. So now we're getting somewhere in the context of she may have left some indicators behind of where she's going because she sent information to him on where he should meet her. So if we follow this TCP stream of the email, it gives us all sorts of cool information of the entire creation of the email. One, a very important one, is where it says auth equals login plain. So another boon for us that's not encrypted. However, the username I highly doubt is this, and I highly doubt that that's her password. But if you go down, the message at one point, it mentions base 64. And so this is base 64 encoded, which is something that we can decode on this box. So if we echo pipe that to base 64 -D for decode, and it doesn't like to print new line characters, unfortunately. So there's always some trouble with the reading it, but this right here is the email address. That's cool. So let's see if we can decode the password, which I will admit I'm not fully up on my forensic investigation laws, so I don't know exactly how legal this would be in a real scenario, but and there's the password. So we've successfully captured the username and password to log into the email for Anne, and in an actual scenario, assuming if this is legal or not, we could contact AOL and have a subpoena to have them confirm that it is actually Anne who has that email address. But another interesting thing about this part is not only does it give us the message again, but this one will actually mention, here's the file name that's attached, secretrendezvous.docx, and then all of our information, which I don't feel like copy and pasting out of this. And We could just, like we did before, we could save the TCP stream, but there's another cool tool we can use called Tcp Flow. And -r is for our capture file. And then we're going to use some criteria to let it know which data flow that we want to capture. So we're going to go with host and type in Anne's IP address and the port that she's communicating on. This one was using, I'm going to double check, but I'm pretty sure it's 1038. Yep, 1038. Keep forgetting to change directories. Alright, so now we have two files with, it names it after the IP address and port of the flow and which direction it's going in. So in this case, we're interested in the one that starts with 192. And we're back in the Bless hex editor again. And this one is SMTP traffic using MIME format. So in this case, the magic numbers we're looking for are going to be 0D0A and then 0D0A again. And that's the signal that a file transfer is about to begin. And we also want to look for the file name, which is right here. And then here's our 0D0A, indicating that's where the starting. So everything past this until we get way down to the bottom is going to be file contents. So we're going to grab all of this, cut it out, and then down at the bottom of the file, sometimes VMware, sometimes. We're going to look for that again, but we're going to need to find it where we can confirm it's the end of the file. So this, where it says next part, indicating next part of the message. If we back it up a bit, right here, 0D0A. And there's also 0D0A down here, so if we had cut it from that point on, the file wouldn't turn out right. And assuming I did it correctly this time, the file will hopefully... So this one we're going to call it, just call it file transfer. Easy. Now this one, because of the formatting that it was sent in, is going to have some line breaks. So we need to quickly use from DOS to get rid of those. And then it's also in MIME format, base64 encodes it if it's a plain text sense. We're going to have to decode it from base64 as well. In this case, we'll call it, let's call it file.docx. Make our life simple. So if this worked, we should now have a copy of the file that was transferred. Like I said before, again, we'd be making a copy of this and doing all sorts of stuff like that. But so here's the file they sent, giving instructions to meet them at a rendezvous point near the fountain at this location, which appears to be something on Google Maps. So now we can inform the police that this is very likely where she went. They ran off to Mexico, so you're probably going to have to extradite if you want them back. So those are the fun kind of things we get to do with forensics. You can view messages people are sending, get files that were transferred, as long as it's not encrypted, because that's kind of a bummer. So one thing with this too is, like, we did all of the file carving manually, which is a really good way to do it if you know what you're looking for, because a lot of automated tools tend to not always perform well. For this example, for the first one, I was actually going to use an automated tool whose name I won't mention, because I wanted to have one of them manual, one automatic, and it just would not work. It couldn't grab the file properly. But there is one automated tool that works fairly well, although I wouldn't necessarily recommend that you always use it like in a forensics investigation. But Network Miner is a handy automated tool. And we'll just do the one that we just did. So it'll load it in, and all that information that we just spent, 15-20 minutes finding is all right here. There's AOL IP address, here's ANS, with every piece of information about it you could possibly want: host name, MAC address, operating system, how many packets were sent from them, how many they received, all sorts of fun stuff. There's messages, so we can read the emails automatically. It parses credentials, so there's the username and password, and it pulls all the files. So that file that we pulled manually from the hex editor, this does it automatically. So this is an awesome tool, but again, I don't know if I would necessarily always trust it for an official investigation. You might use this and doing it manually just to verify. But yeah, that's basically network forensics as an intro. Does anybody have any questions?
Could you repeat what site you had the forensic stuff on?
ForensicsChallenge.com. Highly recommend it. It's a lot of cool stuff. I believe most of them came from, they were originally done at like DEF CON, and then they put them online for everybody to use afterwards. So some of it is a little outdated. Like I don't know how many people use AOL anymore, but
You'd be surprised, actually.
yeah. Another thing is I'm hoping to find some sources in the future for dealing with like at least a little more encryption. I know on certain levels there's nothing you can do, but I'd kind of like to see what you do in a scenario when there's encrypted traffic, because obviously that was unencrypted and it was a piece of cake to find all the files and messages. But any other questions?
How many of these have you gone through?
So far 2 or 3. I say 2 or 3 because I did go into a third one, just not very much. So I haven't spent a lot of time with it because I've been working on other things, but I'm hoping to spend a lot of time with them.
How many of these tools were new to you before you started doing this?
Most of them, I've used Wireshark before, that was it. So, but I highly recommend them. Most of them, if you have a SIF box, most of them are on there. It's got Wireshark, it's got TCP Flow, it's got the Bless hex editor, it's got, it's even got the one that I was going to use that didn't work. So, it's got, from DOS base 64, all that's on there. I think I had to install Whois, as a matter of fact, which is weird because most computers should have that. But, and then Network Miner is on my Windows machine and is primarily designed for Windows. And I guess I've been told you can get it to work on Linux, but my experience was not positive, so that's why we're using it on my Windows machine. But that's a fun tool as well.
For the challenges, are there kind of walkthroughs as well? If you're hitting your head against the wall and you want to kind of get that push to get to where you can do something, or is it
not,
here's the challenge, good luck?
Yeah, not on the website. There's no walkthroughs. That one's pretty much just here's the PCAP file, here's the information of this is the MAC address you're looking for. Here's what we want you to give us.
So they don't even
go
tell
find
you
it.
These are the tools that you have on
Not really.
Okay.
I got my information from, I bought a book on network forensics, which I do recommend. The title is Network Forensics, Tracking Hackers Through Cyberspace. It's a Pearson book. I think it's a textbook, but it's really good. It's got a walkthrough for like at least, I think 5 or 6 of the scenarios that are on there. So that's a one that I would recommend. Anybody else?
Quiet.
Thank you.
Yeah, thank you.
Now comes the grading.
Are there any topics people are interested this year? Anything from red team, blue team, purple team?
What are you interested in, Kyle?
Well, I'm always interested in everything, Kate.
He's
Then
more
why
fit
ask
in
us?
blind.
More ICS stuff.
ICS?
Are you guys able to go into dissecting malware at all, or is that kind of proprietary stuff that you can't really divulge?
Yeah, we can do that.
Yes. Okay.
I second that one.
Wireless.
Something on what about wireless, sir? Mr. Wireless Guru there, who's done a talk on wireless.
Intercepting wireless transmissions using Wireshark, or did they find wireless red team in Wireshark?
Wireless red team.
Did they actually incorporate
Kate, how do you feel about wireless?
Hate the pineapple. Oh my god. I could do it better. I'm going to. What's this guy?
But you have a pineapple.
Maybe not.
You have a patent.
I actually need 10 pineapples.
Okay.
Is that what you named it?
If you guys think of anything else, definitely let me know on Twitter. I will, like I said, try and hunt people down.
Or IRC?
Or IRC. Either one. Doesn't matter.
Oh, I'm sorry. IRC. Slack.
I sit in both, so I don't care. I get pings on both of them at the same time. I'm just like, oh look, notices. 3 o'clock in the morning. Thanks, guys. Kyle joke.
That's the only reason we use IRC.
Otherwise, yeah, we have a misec talk in Lansing and Southfield. Lansing is another process execution forensics. So he's basically, what was his name? Josh Awesome is actually giving a talk up in Lansing. So if you're interested in that, come on up. It's right on MSU's campus. Southfield will be having a talk. I'm going to be giving it. It'll be on just an intro to memory forensics, basically playing around with volatility. So I think I've done that one here before. If not, I can do it again. Gets better every time. My examples get better and better. Cool. Otherwise, that's it. If everybody's interested for a little social, I think I'm going to go over to Nightlight and get something to eat because I haven't eaten. If you're interested in doing that, then you're welcome to join us. Otherwise, that concludes the first misec Jackson of 2017.